Hi, this is Adrian from Live to Learn Academy, and today we're going to be going through lesson 8.4, Laws of Logarithms. For those of you who are new to this channel, feel free to subscribe to more videos like this where we go through the advanced function textbook on Mondays to Fridays at 3 p.m. But without further ado, let's get straight into the lesson. So guys, for this lesson, chapter 8.4, there are a couple more rules that we're going to add on to piggyback off of our lesson in 8.3. So in 8.4, I want to give you some more rules to follow when it comes to evaluating logarithms and using these laws of logarithms to solve these equations. So the first rule I want to talk to you guys about is the product rule. Okay? And the product rule basically states that if you have a logarithm as such, where two numbers, x and y, are being multiplied to each other, and they have a base a, you can actually split this up and add the two logarithms. So it's interesting. Two variables, x and y, when they're multiplied to each other, you can actually split up the equation and add. So multiplication and addition are very, you can think of them as brother and sister, okay? The reason I say this is because we have another rule as well called the quotient rule. Now, in the quotient rule or the quotient law, if you have a function like this where there's a quotient, meaning the numbers are being divided by each other, we can actually split this up as a subtraction equation. So notice how when they're divided, we end up subtracting the variables. But when they're multiplied, like the product, we end up adding the variables. So multiplication and addition are like brother and sister, and division and subtraction are like another set of brother and sister. Okay? So you have these two rules. The third rule is you have the power rule. Now the power rule is something that we discussed in 8.3, but basically what it states is if you have a logarithmic function that looks like this with an exponent r, we can actually bring the r to the front of the equation. Okay? We can bring the r to the front of the equation. We just drop it down. So you're able to do that in the product rule. And there's one last rule that I want to let you guys know about. And this rule, I don't think it has a name necessarily, but let's say you have a function that looks like this, log 3, 6. You can rewrite this function as log 6 over log 3. Okay, so notice, if you ever have something like this where you have a number and a different base, where the number and the base are different, you can actually rewrite it as a division statement. Okay? So I want you guys to, if you want to pause this video, maybe take a screenshot of these rules, these 4 rules I gave you, and really put this on your cheat sheet when you're going through these questions that we do in class. So let's go through some examples. I have some examples directly from the textbook. Let's work out our knowledge. So the first one, we have log 5 plus log 7. This one is pretty easy. Since we're adding, we can just say this is the same thing as saying log 5 times 7, which is the same thing as saying log 35. And that's your answer. Let's look at B. Log 3, 4 minus log 3, 2. So this is the same thing as us saying log 3, 4 over 2, which is log 3, 2, because 4 divided by 2 is just 2. Now, one thing to note, guys, is when you look at these equations, notice how they have to have the same base. If the functions don't have the same base, we're not going to be able to actually use this rule. So this is very, very important. They must be the same base when we're doing these rules. Okay? If they're not the same base, we can't use a rule. So if you look over here, this question doesn't actually have a base. If you get a question where they don't have a base, you're going to assume that there's a base 10. Okay, you always assume there's a base 10 if it doesn't have a base. But if you look at part B, they actually do have a base, which is base 3, and then we can go from there. So this is just another check, I want you guys to know as you go through these questions. Okay, let's look at question C. Log MA plus log MB. So because they're adding and they have the same base, which is M, this is just going to be log MAB. And that will be your answer. We just leave it as in variable form because we just have variables. Let's look at D. Log X minus log Y. In this case, we're assuming base 10 because it doesn't specify. We assume base 10. And then we can rewrite this as log X over Y. So I'll move this down. Let's look at the next question, question E. We have log 6, 7 plus log 6, 8 plus log 6, 9. So when we have log 6, 7, log 6, 8, log 6, 9, we can say this is log 6 of 7 times 8 times 9. You might need to use your calculator for this one, but 7 times 8 times 9 is just 504. Okay? So now let's go to question F. You have log 410 plus log 412 minus log 420. So the way I would do this is I would say it's log 4. Now 10 and 12 are added, so it's going to be 10 times 12. But because it's subtracted after, so this is a mix of addition and subtraction. So the 10 and the 12 are going to be multiplied, but ultimately these are going to be divided by the 20. So this is something important to note. The 10 and the 12, in this case, the addition is actually what's going to cause this right here, but the subtraction is what causes the 20. So now, when we do this, you get 10 times 12, which is 120, divided by 20, which is 6. So you get log 4, 6. I should have squared these ones. Cool. So this is a simple way of how you use the product and quotient rules to evaluate these logarithmic laws and expressions. So let's move on to some other logarithms that involve a combination of some of the power laws that we discussed as well. So if we look at this, right, let's look at 6a. We have log 25, 5 cubed. Now, I know 5 cubed is just 125. But now that I have log 125 base 25, I can actually rewrite this as log 125 over log 25. Now it gets a little interesting because I can use my knowledge from chapter 8.3 to say log 125 is just the same thing as saying 5 cubed. And then log 25 is just the same thing as saying 5 squared. Now using the power law, I can say this is 3 log 5 because I'm able to bring that to the front. And I can say this is 2 log 5. And then I have a log 5 and a log 5 at the top and the bottom, so I can just simplify this to 3 over 2, and that's your answer. So this one was a little interesting, right? We evaluated the 5 cubed to get the 125, and then we made this step right here is the key step, which is the division statement. Once we made the division statement, then we found a common base so that we can cancel it out. So let's go to question B, 6b. We have log 6, 54, plus log 6, 2, minus log 6, 3. This one's pretty easy. We can just say log 6, 54, and 2 are going to be multiplied to each other. And the 3 is going to be divided out. So we have log 6, and then we can put this in our calculator. 54 times 2 divided by 3, which gives us 36. But notice here with log 6, 36. Is there a relationship between the 6 and the 36? Yes, there is. I can rewrite this as 6 squared and then I can drop the 2 to the front, and then I'll just be left with 2. Because the 2 drops to the front, and log 6 is just 1, so all I'm left with is the 2 at the end. So you see, sometimes you may think you got it all the way, but you didn't fully simplify. Okay, so in these types of equations, guys, in these types of questions, you guys have to really fully simplify to the bare bone to get the simplest answer. That's how you're going to get full marks. So now you have log 6, base 6, root 6, okay? So let's look at this. You want to chop it up piece by piece. So this, I'm going to change this to 6.5, 6 to the power of 1 over 2, right? Because the root 6 becomes 6 to the power of a half. Now, if I do this, 6 times 6 to the power of a half is just adding the exponents. So this becomes 6 to the 3 over 2. Then I simply drop this to the front, and all I'm left with is 3 over 2 log 6. Log 6 cancels because we know that's 1, so I'm just left with 3 over 2 as my answer. Let's look at D. Log 2 root 36 minus log 2 root 72. So this one's also interesting, right? Because I can change this to, because of they're being subtracted, I can change this to root 36 over root 72. And now root 36 is just going to be 6. But root 72, if we put root 72 in our calculator, we're not going to get anything. So we can just leave this as root 72. Because if we do root 72 in our calculator, all we're going to get is a decimal. So you want to leave it in radical form for this question. Okay, we got 2 more questions. Log 3, 54, plus log 3, 3 over 2. In this case, this one's actually pretty easy. We just take log 3, and then we have 54 times the 3 over 2, because it's the product rule. So we end up with log 3. 54 times 3 divided by 2 is 81. And over here, there's that extra step. So don't finish here. You got to realize there is a relationship between 3 and 81. The relationship is 81 is the same thing as saying 3 to the power 4. And then from here, I can bring the 4 to the front. And then from here, I'm just left with 4 as my answer. So this is an important step, right? That 81 gives you that 3 to the 4, which helps you bring that 4 to the front. And let's go to question F. You have log 8, 2 plus 3 log 8, 2 plus a half log 8, 16. This question is actually really interesting, and I'm going to tell you why. The first guy, we're just going to leave as 8, 2. But this guy, you see how you have the 3 as the coefficient? You can actually, in the same way you can bring an exponent and bring it all the way down using the power rule to become the coefficient, you can also do the reverse. So I can also bring that coefficient up as the power. And the reason I'm doing that is because now I'm going to have log 8, 2 cubed. And the same thing I'm going to do with this half. I'm going to bring it to the power of the 16. So I'll have log 8, 16 to the power of a half. And let's see how this all plays out. Let's clean this up. Log 8, 2 plus log 8, 2 to the power of 3 is just 8, plus log 8, 16 to the power of a half is just the same thing as the square root of 16, which is 4. And then from here, now we have a simple product rule, where it's log 8, 2 times 8 times 4, which is log 8, 64. And now, what is the relationship between 8 and 64? 8 and 64 will become 8 squared, which just becomes 2 log 8, 8, which just becomes 2. So this lesson, guys, is really, really similar to the last lesson, and it's really just a bunch of practice. But the main thing I want to state is you have to get the rules down. If you don't know the rules, write down the rules on a cheat sheet and refer to your rules at all time. The only way you're going to get better at this lesson, guys, is you have to do the practice. I'm not smarter than you guys are. I just done more practice than you. I've done more questions. Okay? So there's a discipline in being able to do these questions and go through them. However long this video is, you can see I went through 6 questions here and I went through 6 questions here, which is 12 questions. In my opinion, you guys should do at least 20 to 50 questions on just this to make sure you got it down pat. But that's it for today's video. If you have any questions or need tutoring, feel free to click the link in our description and our team would love to get in touch with you. But without further ado, I'll see you guys in the next lesson.